Hi, this is Mr. Max with paper 2 extended level that was written in 2021. Okay, so we are going to have a look at this paper. Again, remember what I said. This content is useful for all learners doing ordinary level or students or even helpful information for teachers. All right, so without further ado, let us get right to the question paper. Remember, there's a link of this on the description below of where you can download the question paper. Right. The first question again is just some calculator work. So you grab your calculator and you just punch in. Make sure your calculator is set to the right settings. Okay, so 10 plus 0.6 times, in bracket you have 8.2 squared plus 5, close the bracket, hit enter, and then just want to make sure 10 plus 0.6 plus 8 point, yeah, so we need to go back there. That needs to be 8.3. Okay, now we have got our answer 7.37. So 7.37, just to play it safe, write your full calculator display there and then write the required rounding. Okay, they say must give you answer to 2 decimal places. Question 2a, write AD as a product of its prime factors. You can also do this very easily with your calculator. You see there is a fact button there for factorization. What you can do, you say AD equals shift and then you hit that button. It gives you the number in prime factor form. So that's 2 raised to the power 4 times 5. Ideally, you can take the long route, start with the first prime number, and so on. The lowest common multiple of 30 and 45, right? So I'm just going to write each of those numbers also as a product of their prime factors. So 30 would be, most of your calculators can do this, 2 times 3 times 5 times 3 times 5. 49 is 3 squared times 5, but I'm just going to do it any way. 45, I mean, it's going to be 3 squared times 5. So that is 3 squared times 5. Right, so the lowest common multiple is going to be, well, you have to write down what is not there. So the 2, the 3 raised to the power of 2, and the 5. Always pick the one with the biggest index. So 2 times 3 squared times 5. Well, that gives you 90, and 90 is the LCM of 30 and 45. Question 3, you have to simplify. Remember, many ways to do this, but essentially 8 is nothing but 2 cubed, and this should be raised to the power of a third. P raised to the power of 6 also raised to the power of a third, and then obviously you multiply those indices, you get 2, and then you get P squared. 243, when you are getting to question 3, A, 243 can be written as a power of 5, and if you don't know, you start a power of 3. You say 243 equals to, you get 3 raised to the power of 5. So this is 3 raised to the power of 5. Well, should still be raised to the power of x equals to 3 squared. Now you can actually drop the indices, so it's 5x is equal to 2. These two, they multiply over, and then you're going to have x is going to be that 2 divided by 5, and you can give any equivalent answer, whether you write 0.4 or 0.4, still the same thing. Question 4, they say if x is a number that is greater than 4, so let's just say, for example, x is equal to 5. This will help us when we have this type of scenario. So 4 over 5, 5 over 4, and 4 minus 5. Okay, just to make sure that you can answer. So this one here is 0.8. This one here is going to be 1.25 if you work it out, and 4 minus that is negative 1. Right, so ascending order, starting from the smallest. So the smallest one is obviously this one here, which is, so you're going to write these answers down, and the second one is 4 over x, looking at that. So 4 over x, and then obviously followed through by x over, oh my goodness, x over 4. So you just use any number greater than 4 to, and then you work it out, and then you see what you get, okay? So this one here is the first smallest, followed by 4 over x, and then x over 4. So far, so good. Let's go to the next question. You're supposed to make uh, W the subject of the formula. Again, you can go ahead and you can put this in brackets. Okay, you can even put this one over 1 if you want to. And once you cross multiply, you get V, and keep them as capital letters because they are capital letters. All right. So the objective is to make W. No need to multiply out. You have W plus 3 equals to T over V. And now W will be nothing but T over V take away 3. T over V minus 3. Okay, you can also get another answer, anything that is equivalent to this. For example, you can have T minus 3V and everything over V. The V's they cancel, will give you the same thing as this one. Question 6. In 2018, a small country had 720 million Namibian dollars to spend. The pie chart shows how it was spent, how much money was spent on education. So if you look at education, so this represents 1/4. So 1/4 of 720 million. Now I'm saying 1/4. 1/4 comes from this whole thing is 90 degrees over 360, which simplifies to 1/4. Okay. Right, once you multiply out, you'll get 180 million Namibian dollars. Right, so I don't have a protractor, but you will obviously um, use a protractor, and then you're going to measure this particular angle. When you use your protractor, you measure that angle because the question says you should measure. Of course, if you have the paper in front of you, you should get anything like 120 or even 121. So plus minus anything in this region. Okay, some people they could get 120, 121, anything in that region when you measure it. So you take your protractor and you measure that angle. Of course, you need to use that in order to solve Roman 2, how much money was spent on social services. Social services is the second angle that we just calculated. So you take that answer that you got and you put it over 360. And of course, you multiply that by 720 million. You can write millions with the 6 zeros, but this is also fine. So this answer here is nothing but 240 million. What fraction of the total was spent on other services? Other services is 54 degrees over 360. So you're going to have 54 over 360. And well, of course, you are going to simplify that. And when you simplify that, just use your calculator and you should get 3 over 20. So that's 54 over 360. Hit equal to 3 over 20. And you are good to go. Let's go to the next question. So question 7, the table shows the time, T minutes that 400 people take to complete a test. Okay, so there's going to be a bunch of things that I'm going to do because the nature of the question involves something with cumulative frequency. So cumulative frequency, remember, cumulative frequency is the sum of all the frequencies of the previous frequencies, and they add up to a certain value, and that value in this case should be 400. Okay, cumulative frequency, remember, cumulative means how much so far, or what we also sometimes refer to as the running total. So in order for us to find, we have a 10 there, so this next one will be 10, the previous one 10 plus 90, so this is going to be 100, and then we use 100 plus 135 as we remember as the running total. That's 235, and then you have 235 plus 85, Okay, that gives you 320, and then you have 320 plus 70 here will give you 390, and then obviously 390 plus 10 will give you the value of 400. Okay, so these are the things that you are going to put up in your cumulative frequency. The 100 and the 400, as you can see, was given, so you were adding the totals of the previous, so the 90 should be added with the 10. Okay, so you've got 10 there, you add whatever that answer is, 135, whatever that answer is, add, and so you go along until you get to where we are. Okay, right, so these are the values that we are going to write here. So 100 is here, then 235 is here, then 320 is here, and obviously 370, let me just 390 rather, so this is going to be 390 followed by 400. So you get 1 mark for any 2 correct values there. On the grid that is on the next page, we're supposed now to plot those values. Okay, right, so I hope you have your paper ready, and okay, make sure that you understand your scale. So on the y-axis, 50 divided by 10, so one little block represents 5 units. In this case, the cumulative frequency would be 5 for each block, and obviously on this one here on the x-axis, this is very straightforward. You have 10 blocks, so 10 by 10 is 1, so one block represents 1 minute. Okay, so time for us to plot. So remember from our table, so I'm just going to have our table, I'm just going to write it here so that we can not go back and forth. So less than or equal to 10, well, that was, let's just move it along so we can have proper space. Okay, so we have t less than equal to 10. This was also 10. Then the next one was for t less than equal to 24. This was 100, remember? And the next one is t less than equal to 30. This one was 235. Okay, running out of space there. So let's just write it nicely. Maybe I can use different colors. So it's 235. The next one will be 320. Next one will be 390. Next one is obviously 400. Okay, so we had t for the one of 320 is less than or equal to 40, and the next one is t is less than or equal to 60, and obviously t is less than or equal to 70. Okay, right, so these are the things we are going to plot. Remember, I'm just rewriting that from the table over here. Good, so let's plot. So for t less than or equal to 10, well, of course, you have, remember, your answers here will be range. So we go to 10, and we are now looking for 10. So that is, remember, one block is 5, so that's 5. 10 will be here. All right. The next one, obviously, we are going to start this from the origin. The next one, 24. So 24 is here, and 24, we need to get 100. So 24 all the way up here to 100. Right there. Then 30 goes to 235. All right, so let me just go down a bit so I can have my 235. So 30 will be 235. Just make sure, because as I am moving along, I just want to know where my 30 is. So 30 is here, 40 will be here, 60 will be here, and 70 will be here. Okay, I'm just moving my graph so I can plot. So for 30 is 235. So for 30, if that is correct, for 30 we'll have 235. So that means 200 over there, 205, 210, 215, 220, 225, 230, 235 is going to be right there. Okay, then for 40 it's 320. So of course, 320. 300 is over here. So 305, 310, 315, 320 is there. The next one is looking back at my values. So the next one is 60. 60, we are looking for 390. So 60 is over here. 390, so 390, 300 and so remember that's 350 right here, 360, 370, 380, 390 will be right there. The last one, it goes all the way up to 400, and it's not supposed to bypass that part. So you're gonna draw the curve, also known as an ogive, or you can call it whatever you want, but it's a cumulative frequency curve. So we are going to draw that curve. All right, so that curve is going to obviously start here nicely, and then it's going to go up. Remember, must be slightly different. Maybe I need to start again just to make sure that my curve is smooth. All right, makes sense. So I continue. Where we're at. So don't use a ruler. Oh my goodness, let's start again. Nicely for that one. Maybe I start from here. Remember, you have the luxury of using or taking the paper, and then obviously you are going to turn the paper around so that your inside of your palm can be there, and you can make a smooth curve like so. Right, there we go. I think that's the best that we could have done for this. Make it a bit smaller, then you have an idea, right? It's a pretty decent curve, don't you think so? Good. Right, so we are going to answer now questions from the curve. This is 3 marks for 2 marks for all the 6 points plotted, and 1 mark for a smooth curve. So obviously you lose a mark if all the points are not plotted. Good. So the next, they say you must use your graph to find the median time. So the median time is half of your total frequency. So I'm just going to write the stuff here. So I have for Roman 1 a half of my total frequency, a half of 400. Well, that is nothing, but if you know half of 400, that is 200. So we go to 200, and we're gonna have our arrow. So let me just bring in an arrow. We change maybe to red, so from 200 all the way up to here. Then from here we're gonna go down. So maybe I'll make that a bit smaller so that can be able to read down the information properly. So from where it now go from here, slightly a bit off, right? Slightly a bit off, somewhere there. Okay, so yours, remember, will be slightly different than mine, but it should be more or less in the same range. I think you'll agree with me that my arrow should have been more or less over here, the way I drew it. Okay, so 25, 26, 27, 28 minutes. So I'll say I get 28 minutes there. So that is 28 or 29. So you have got a range. So this one here will be 28 minutes. That is the first Roman one, where they're asking me to find the median value. So go back and then you answer that. The median time here is 28 minutes. Now, when they were marking this, they accepted a range, and the range that they accepted was from 27.5 all the way until 29. So this was the acceptable range. So my answer is within range, and therefore my answer is good to go. The next one is the interquartile range. So the interquartile range is the upper quartile minus the lower quartile. So upper quartile in order for me to find the upper quartile, I need to find 75% of my frequency. So 75%. So before I go back and draw those lines, I'll say, okay, for the second part, they say interquartile range is Q sub 3 minus Q sub 1. So I'm going to have 3/4 or 75% of my values, my total frequency, take away 1/4 of that. So I know that this is 300 minus 100. So I'm looking for the time. So I'm going to go to 300 and 100 respectively, and also draw my arrows again. So 100 is over here, comes all the way up to there. Well, and then you read down from there all the way perhaps up to here. Okay, so well, look at that. That is 21, 22, 23. Let's say 23.5, or let's just say, to keep it steady, I will say 24 minutes. Okay, then I'm going to do the same all the way for up to 300. So 300, let me just change the color here. So maybe 300. So that's going to go all the way here. And then I'm going to draw down from there. So I'm just going to make my graph a bit smaller so that I can be able to draw my line. So starting from there all the way, it has to be a straight line up to here. And we'll find what that value is in a bit. Let's just improve our resolution here. Okay, so that is, let's suppose that is 35, 36, let's say that's 37 minutes. So my interquartile range in terms of the time is going to be, I had 37 minutes minus, let's say, 24 minutes. So my answer for this part is nothing but 13 minutes. All right. So that is from my graph, the way I drew it is going to be 30 minutes. So I'll go back and I'll go answer my question. So it's 13 minutes. Again, also when they were marking this paper, they also gave a range of acceptable values. And in their case, they accepted anything between 12 to 14 minutes. As you can see, my answer is within the acceptable range. Now they are looking for the 15th percentile. So go back to your graph. Okay, so basically I'm working down here. So I'm going to have Roman 3. Let's have Roman 3 here. So they are saying the 15th percentile. So that's like, let's work 15% of our total frequency, or 400. Well, 15% of that is 60. So we remember what you are looking for is you are looking for the time. Okay, use a graph to find the 15th percentile. In this case, we're going to go to 60 because we have calculated that to be 60 and our frequency. And once we are at 60, we are going to read down the information. Okay, and then take your ruler and then you start again. So finding the minutes. All right. So again, as I was saying, so let's bring back our ruler. So let's keep it red. So 50, 55, 50, 60 will be over here. Because remember, each block there counts something like 5. And then coming down here again, so, right, I'm just going to go to the nearest thing there. Okay, so here was probably, if you look at what we have in terms of 60th, we read down, and I'm getting something like the 15th percentile. All right, so that's 15, 16, 17, 18. Let's suppose about 19. Can you see that? 19 minutes. Good. 15 percentiles, 15% of the values. So I get 19 minutes. Again, the answer would be in an acceptable range. So we just go back and write down. So they say 19 minutes. And when they were doing marking this paper, they accepted a range of values that you would get, acceptable values between 18 to 20. You can see from my graph, I am still within range. Then they say the total number. Use the graph, find the total number or the number of people who took more than 50 minutes to complete the test. Okay, so more than 50 minutes to complete the test. Let's go back to our graph. Remember, 50 minutes is over here. Okay, just make it a bit smaller so that everything can fit in properly. Maybe a little bit more, 50 minutes. All right, so there is a certain part that we are looking at in order for me to find that. So I need to know, let's say, more than 50. If I were to say, where is 50 now? Since the graph is a bit too small, so let me just zoom it back. Okay, so back again, make it bar bigger. Good. So 50 will be all the way. 50 is here, so I'm looking at this particular one. All right, let's just continue that. That line from there. So it's all the way here. So when I look at it now, let's say I'm taking this one on top, right? It's a bit out. So let's say that is 355, 365. Let's say I'm saying 365. And then the people more than 50 is going to be the difference of these two, rather. Okay? So you can say 400 minus 365 from my graph, the way I have it. So it's 400 minus 365, so it's about 35 people. Okay, 35 people. Could be that the way I drew my graph, it's a little bit out, so I'm getting 35 people. 35 people have scored more than 50. Okay, so again, so if I go back, the number of people who took more than 50 to complete the test, more than 50 minutes rather. So I'm getting, from my information, I'm getting 35 people. But then again, there was a range, an acceptable range when this paper was drawn. Because remember, our curves are not going to be identical, but our answer should be within an understandable range. So anything between 30 to 45, and you can see mine is well within the range. So that's how it's technical, right? There's a lot of drawing and things that you need to do because you're getting marks for those things and so on. So take some time when you solve this question, and maybe you can come and do that towards the end if you get such questions in the examinations, if you're afraid that you will take longer than normal to solve this question. And use your space wisely the way I did over here. Question 8. You just make it smaller a bit. The diagram shows a cube of side length 8 centimeters. They want us to calculate the length of BS. Now, in order for me to do that, I'm going to have to bring in maybe a line. It's like so. Okay. So on that dotted line. So maybe my line is like so. And a triangle like so. And what you'll also now see is that this here is a right angle triangle. And for me to find this distance over here, right? So I'm going to write it in blue so I can find this distance over here. And this one is also 8, okay? And I'm looking for BS. So in order for me to find first BD, I'm going to take the triangle on the bottom, right? The triangle under here. So I'm going to say triangle. I'm just going to draw a right angle triangle because remember, this triangle here is also right angle. Okay, so just draw yourselves a right angle triangle like so. And we are looking for BD at the moment. This is A. This is a right angle triangle. We know that this here is 8 centimeter. We also know that this one here is 8 centimeter because that's right there. So finding x, we're going to use Pythagoras. So when I want to find x, I'm going to say Pythagoras theorem. You simply say 8 square plus 8 square. Well, Your answer there is 8 root 3. I'm just going to leave it as 8 root 3. So now I'm going to draw the triangle so that I can find my missing side. So the triangle I'm looking for now, draw yourselves a right angle triangle, okay? So we have got triangle B, S is over there, and obviously this is going to be D. So let's fill in the missing information. So we know that D to B, the one we just calculated, D to B is it 8? Let's just make sure about this value on the calculator. Let's grab the calculator quickly. So 8 square plus 8 square. I think it's 8. Yeah, it's not 3. No. Okay, so let's just change this value back to what it was. All right, so again, that is x, my x being dB, so dB is 8 root 2. Okay, then d to s is 8. So we are looking for this value here. I'm just going to call it y. This is the value that we are looking for. So you can use Pythagoras as well there. So using Pythagoras, we'll say BS equals 8 square, because the hypotenuse, plus 8 root 2 all squared. Let's grab a calculator and make sure we get our answer. So once we grab our calculator again, so we have under the square root 8 square plus, and in brackets, 8 root 2, square that. Well, let's just get our root 2, get out of that, and we square that. Okay, we get, yeah, this is the answer. We get 8 root 3. Now this is an answer in third form, which you can go ahead and leave your answer like that, or you can give your answer as 13.85 or 13.9 to 3 significant figures. Okay, so I'm going to have to 3 significant figures, I'm going to have it as 13.9. So anything within that range. Now, remember, there are many ways you can work that out, but to me, that is one of the easiest way to find that. Now they say calculate angle SBD. So we have our right angle triangle, the one on top here. So if I have my right angle triangle, so that is SBD, it's right angle here. I know that this distance here is 8. This is 8 root 2. I'm not going to use this one here, but you can go ahead and use it if you want to. So this is the angle that we are looking for. Right, I'm just going to use the distances we have originally. Okay, you can use, once you have 3 sides given of a right angle triangle, you can use all the 3 ratio. You can use the tangent, you can use the sine, you can use the cosine. Right, I'm going to use the tangent. So tangent of theta is opposite, which is 8 upon 8 root 2. Well, of course, this is something that can be simplified further, but there's no need for that. So the inverse tangent of whatever this is here is what is going to give me my solution. All right, so shift inverse tangent. Make sure your calculator is on degree mode. So you've got 8 upon 8 root 2. Okay, here you don't have to worry about things like rationalizing the denominator. Of course, it's also not necessary for you to know that. So 35.264. So it's about 35.264. I'm just going to write it over here. So angle SBD is equal to 35.6, no, 0.2, and it goes on, right? So 35.3 degrees. Again, they allow a certain range within this when they were marking this, but that is how you approach that question. Right, that brings me to question 9. So you should be familiar with vertex form. You also look at paper 4 that I did. I was using the axis of symmetry. In this case, I'm not going to use the axis of symmetry. I'm going to write this in vertex form. So I'm going to say f of x, I'm going to replace it with y, because y is equal to f of x, all right, the function of x. So that is x squared plus 4x minus 6. So what I like to do is I bring that 6 first back, so I've got x squared plus 4x, so I'm basically finding using difference of two squares. Half of 4 is 2, so I'll have x plus 2 on the side equals to y plus 6. Right, so please have a look at most of the videos so you can understand. So let me just bring in why we take half of the middle term. Okay, so half of the middle term, which is half of that. All right, half of that, before I square that, half of 4 is 2, and I'll have a 2 here. So before I square it, this is what's going to come inside the brackets over there. Now when you square this, you're going to get 4. So what does it mean? There is a 4 here if you multiply this out, so I must also remove a 4. Let me just explain. We have got x plus 2, all right, times x plus 2. When you multiply out this, you get x squared plus 4x, 2x plus 2x plus 4. Can you see this part of course look like that part over there, but you've got a 4 that is now here when you square that, so you need to remove that 4. Okay, so once I've done that, now I can go back and I can bring my 6 back. So I'm going to have y equals to, so x plus 2 all squared minus 4 minus 6, because we have to bring the 6 back. Okay, when you are using this method, many ways that you can do this. At the end of the day, this is x plus 2 all squared minus 10. P, therefore, is this value here, which is 2, and Q is this value here, which is negative 10. Many ways that you can do this in order for you to find the value of P and the value of Q. Right, now they are saying use your answer in part A to solve. Remember this equation, this is standard form, right? Ax squared plus bx. This what we have over here, x plus 2 all squared minus 10 equals to 0. This is vertex form. So essentially these two things are exactly the same. But I'll use the one that I have here in order to solve. It's easy. So I'm not going to use completing the square or the quadratic equation formula. So you simply say x plus 2 all squared equals to 10. Move that 10 over. We're looking for the positive solution. So we're going to take the positive square root of 10 because we need to get rid of that square. Therefore, x will equal to, take away the 2 plus the positive square root of 10. So essentially this is your answer. All right, if you move that 2 over, it becomes a minus, and you hit that on your calculator, you'll get about 1.16, roughly two or three significant figures. So you're going to have nothing but minus 2 plus this positive root of 10, okay, and then you get that answer. All right, we're getting to 10a. We have an inequality here that we should solve. Not complicated in any sense. So maybe you say minus 2x minus x is less than negative 12. Because if you move the negative 12 over, you are going to get, the 12 over becomes negative. So in this case, I have negative 3x is less than negative 12. So once you now divide by a negative, if you divide by a negative, the inequality sign should change direction. Okay, so this sign is going to change. So because a negative changes that, so your inequality sign changes because you are dividing by a negative value. So at the end of the day, x is greater than 4 is the acceptable answer. Right, if you look at this one here, this one is not, you don't have to split them, it's not necessary. So what you do is you divide by 2 here, you divide by 2 here, and you divide by 2 there. So 2 into that is negative 4, and will be isolated, and 2 into that is negative 2. And then your work there is done, okay? But not necessarily. Let me just rewrite because I didn't answer the question. So that's negative 4 less than n less than equal to that. Okay, so this is how you solve the inequality. So it's best maybe if we can write the inequality on a number line, because the question says Find the integer, and it's even bolded. Mr. Max, pay attention. It's bolded. All right. So on a number line, integers are positive and negative whole number. Negative 2 is bigger. Negative 4 will be here. So negative 3 is the only one that will be in there. So negative 4 will not be included, and the only solutions to this type of question will just be negative 3 and negative 2. So it's negative 3 and negative 2. These are the integer values that satisfies that. Right, question 11, you are supposed to solve the simultaneous equations. There are many ways that you can solve simultaneous equations. You can use the method of equal coefficients, but I will use substitution method because the second equation here can be, I can make x the subject of the formula. So this equation, I can say, wait a minute, x equals to 9 minus 2y. Essentially, everywhere of an x in the first one here, I'm going to replace it. So I'm going to say 2 minus 3y equals to 13. So I'm going to replace the 9 minus 2y in that equation. So I'm just going to write it here. Minus 3y equals to 13. And if I multiply out, that is 18. If I multiply out, that is minus 4y. I hope you following. Minus 3y equals to 13. So that's 18 minus 7y equals to 13. We have got negative 7y equals to 13. Let's just improve our handwriting. Oh my goodness. So our handwriting there. So it's going to be 13, take away 18. Of course, you're going to have negative 7y equals to, now remember, if you're subtracting, you get negative 5 as an answer. And y will be negative 5 divided by negative 7. So therefore y is, they say you must leave your answer as fractions. So y is nothing but 5 over 7. Now, if I go back to bringing the other one down, the x equals to 9 minus 2, right? This one over here, find the value of x. So this one was 5 over 7. You grab your calculator and you calculate this one. So when you calculate this one, it's 9 minus 10 over 7. All right, so this is going to give you nothing but 53 over 7. Okay, so that one is 53 over 7. And these are your two answers, and you should give them as fractions. Just want to show you something interesting. Although they are not recommending that you use this calculator, but there's so many places in the world that this calculator can still be used for these segments. Okay, so suppose you want to solve this simultaneous equation, and you go to your mode, you choose 5 for equation. You're going to choose the very first one because you are looking for simultaneous equation. So first one I choose, give you two equations. Our a value is the coefficient of x, so that is 2, hit equal to. Our y value is the coefficient, which is negative 3, so I'm going to say negative 3, press equal to. Our c is our 13, so 13 here equal to. Then we come to the second equation. Our coefficient here of x is 1, so that is 1 equal to, and then this coefficient of y is 2 equals to, and then the value of c is 9 equals to. When you press equal to again, it gives you the first answer. Can you see that? 53 over 7, that is the value of x. Hit equal to again, it gives you the value of y, which is 5 over 7. Essentially, that is why these calculators are not supposed to be used, okay, in these ordinary papers, because you do not show working when you have that. But of course, it's a nice tool to have in any case. Question 12, something to deal with similarity. This also is a very familiar question. You probably have seen it in your textbooks. It is quite over the place. So if I say the area of, because these are tabletops, let's say of the big tabletop, I'll just say big top, and I divide that by the area of the small top, okay, that should give me some k squared. where the k is equal to, I have distances, 120 over 80. So I'm just going to simplify this, and when I simplify this, it's 3 over 2. Since I'm comparing areas, I'm going to take the relationship of the distances and I'm going to square them. So I'm going to say 3 over 2 square. If there was some volume, I will be cubing. What is the big one? The big one has a square of, the smaller one has a square that we are looking for. So we're looking for the smaller one. So the calculate the area of the larger one. So the larger one is unknown. The smaller one is the one that we know is 1 over 4. Okay, as we are given. So from here, pretty much, let's just maybe use some of the space down here. So from here, pretty much, you're going to say 9 over 2 over 4, because this is 9, 3 squared now, equals to x over, let's say 0.25. 0.5 is nothing but 1/4. Cross multiply, so you're going to have 4x equals 2. Yeah? So you have 9 times 0.5, so 9 times 1/4, okay? That gives you 9 over 4 as an answer, which is 9 over 4. And then if you want to isolate x, you will say 9 over 4, then you divide that by 4. All right, you will get 9 over 16 here as an answer once you do that. Essentially, one can also accept decimal values, so some students probably have something like 0.5, 625, but it should be, you must write it out in full because it's a terminating decimal. Question 13. So we've got some circular geometry here. The points P, Q, and R and S, they lie on the circumference of a circle. Then you are told that it's a trapezium with PQ parallel to SR. The point T is on the point SR, such that angle that is formed there is 66 degrees, 35 degrees, and 79 degrees. Right, I'm just going to fill in what I have. Now I know that this angle here is 35, so this one also will be 35. And the reason being, these angles are alternate angles. Then this one here is 66, so this one here will also be 66. Then I can go ahead and calculate the missing one here. And that missing angle, you can calculate by taking the sum of 66 and 35 and subtracting it from 180, because they are angles on a straight line. So this angle here, I've now determined this angle here is 79. There we go. So now I have every missing possible thing that they could ask me to find. Right. Now, you just answer the question. Find angle PTS. Now, angle PTS, well, we have discovered 79 degrees. My goodness, angle PTS is the one that goes the opposite direction. So it is this angle over here, which is 66 degrees. And what is the reason? The reason is they are alternate angles. Alternate angles, those ones that look like a Z or a Z, depending which part of the world you're coming from. Alternate angles. What about alternate angles? Well, alternate angles, they are equal. Right, they say find the angle PTQ. I'm pretty sure I've already established angle PTQ at 79. So see, use your pencil, you work out the missing stuff. Then they have got a bunch of information. They say angle PTQ. Well, I'll make it smaller so that you can follow. Angle P2Q, that angle P2Q, well, is equal to angle RQT. Then angle PQT, that is equal to, let me just change the color here so the things don't look so, it's equal to RTQ. You can have a look there. What can you tell me about QT? Well, QT is a common side. Okay, so you have a look nicely. and then you will be able to distinguish what I have explained there. So therefore, the two triangles, they are congruent. Okay, so if you will take this one here, you flip it around, it will fit nicely on top of the other one. So we can also deduce that this angle over here is 66. Okay, get it? So it's like you take, let's say, you take this triangle, right? And you flip it around and you let it be on post on top of the other one. Q2 will be the common side. This angle 66 will meet that one there. The 77 will meet this one here, but they will have the same common side of QT. Good. That brings me to question 14. The diagram shows a prism with a rectangular base of length 15 centimeters and the width is x centimeters. The cross section is a right angle triangle. Now, they say show that 3x squared minus 12x minus 176 is equal to 0. They also tell you that the volume of the pyramid, or pyramid, my goodness, the volume of the prism is 440. So in order for you to calculate the area of the cross section, this triangle here, okay, I'm just doing the one at the back, but also the one in the front. Defining this area here, which is going to be the same as the one in front. The area of a triangle, the area of the triangle is a half times the base, which is x, times the height. Now here's the thing about the height. They say the height is 4 centimeters less so than the width, so the height is x minus 4. That's the area of that. But if you want to find volume, you take the area of the cross section, you multiply it by the length or the height, you multiply that by 15. That gives you the volume. So basically this is the equation that we have to clean up, and obviously this equation x of x minus 4, goodness gracious, let's just change that. So I'm gonna have x, then I have x minus 4 times 15 equals 440 times 2, because this is a half, and what you do is you multiply by 2 both sides, so you multiply here by 2 and you also multiply there by 2. Okay, so I'm going to have x squared minus 4x, but I'm still keeping it in brackets because I'm supposed to multiply it with 15, equals to 880. And then I'll have x squared minus 4x equals to 880. I'm going to divide that by 15. That's going to give me x squared minus 4x is going to leave me with 176 over 3. Good. I know a bit fast, but you can definitely sort of work this out. So I'm going to get rid of that 3 again. So I'm going to say 3, and then I have x squared minus 4x is equal to 176. So essentially I'm multiplying through out by 3, and multiplying over I get 3x squared here minus 12x equals 176. Ultimately this brings me to 3x squared minus 12x minus 176 equals to 0, and this is what we were required to prove, all right from the beginning. So where is the juice? Squeeze the juice. The juice is in using the formula a half times x minus 4, which is the area of the triangle, times 15 equals that. That is the volume of the form of the prism. Once from there, play around with the formula and you arrive at what they give you to show. Right, so the next thing they say you must solve the equation. So the moment you are told to solve the equation and they say give your answers correct to a certain degree of accuracy, like in this case they say 2 decimal places, then you should think I must use the quadratic equation formula or completing the square. But you can't use you can't use the factorization method. A is 3, B is negative 12, and C is negative 176. Right, so the quadratic equation formula, you don't get a mark for writing it down. Okay, just remember. So times A times that. All of that should come over to A. So let's put the values in. So B is negative 12, negative 12, A is 3, negative 176, and 3. Well, you play around with those things, you'll get two answers. One answer will be when X is positive, one answer is going to be 9.92, or the other answer will be negative 5.92. So I'll have 9.92 and negative 5.92. Okay, very interesting. That I can also show you again on the calculator that I'm using. I can solve quadratic equations pretty much using this formula, and you will see that the answers are going to correspond. So I go again back to equation 5, and then I choose 3 here because that's the format which quadratic equations are. Ax squared plus bx plus c equals to 0. And my a is 3, so I hit 3, and I press equal to. My b is negative 12, so that's negative 12, press equal to. My c is negative 176, negative 176, hit equal to, then you hit equal to again. It gives you one answer when it's positive, so you press SD 9.91. You see where my 9.92 comes from. The second answer when it's negative, because you have a positive and a negative, right? So now when it's negative, you're going to have negative 5.92 to 3 significant figures. Can you see where it comes from? Very interesting, okay? Very interesting using this calculator. But again, you need to work, show without using that calculator. Right, the width of the prism. Remember, you have the width. Our width was x minus 4. So we can't use the negative value here because you can't have a negative distance. So the width, the height, sorry, my goodness, not the width, the height is, okay, the height is 9.92. So once you are now looking for the height, you will say 9.92 minus 4. You use this one. Ideally, and very importantly, you also get the same answer, 5.92. Okay, doesn't matter. That's what you're gonna get. So the height, going back to my shape, remember the height is x minus 4. So you have to choose the positive value of the x that you calculated, because the negative value will give you a negative distance, and distance itself can't be negative. Question 15. You have got three inequalities. They define the region labeled R. So this region R is this is the wanted region. Okay. All right. So that's the wanted region. So you can see this is a solid line. So in the line language, this is going to be the line x equals to 2. This one here in a line, it will be y equals to 2. No, my goodness, y equals to 1. That's what it will be as a line. All right. Equals to 2. The other one, so I have the lines. One line will be x equals to 2. The second line will be y equals to 1. Okay, keep on making that mistake there because you can see it cuts the y-axis. The third line, that one here, you will see that it has a y-intercept of 5. All right, so the third one, I want to write it under here. So the third one will be y equals to, the gradient will be 5 over 15. But the gradient will be negative because the line is going downwards. Can you see that? And it has a y-intercept of 5 because it cuts the y-axis at 5. So ideally, my three lines now that I have is, if I were to simplify this one, it would be y equals to negative 1/3 of x plus 5. But we are not looking for lines, we are looking for inequalities. So this one, x equals to 2, since the 2 is on the right side, the stuff that is on the right side, that is the wanted region. So the inequality should therefore be x is greater than, okay, because things on this side is greater than. So that one is going to be x is greater than or equal to 2. Okay, that takes care of this one here. The dotted one, the stuff is on top, that is going to be y. Okay, it's on top, greater than 1, not or equal to, because it's dotted. Right, for as far as this third one is concerned, the wanted region is below the line. Because it's below the line, we're going to have a less than, and since it's a solid line, we're going to say y is less than or equal to negative 1 over 3x plus 5. Okay, these are the three lines. So you get 2 extra marks for working that gradient and for finding the y-intercept. So as a matter of fact, line 1 will be x is greater than or equal to 2, y is greater than 1, and the third one there is y is less than or equal to negative 1 over 3x plus 5. Okay, have a look and make sure you understand what I did there. Right, the last question, question 16. The first 4 terms of the sequence A, B, and C, they are shown in the table. The first one is not difficult for you to complete. The first term is going to be 5 over, now that's not going to be 5 over 7, but it will be 5 over 8. 3, 4, 5, 6, 5 over 7, rather. Okay. The nth term, also not complicated. On top, it will just be n, because n is the position, like 1, 2, 3, 4. Under here, it will be n, the position, plus 2, because if you say n plus 2, 1 plus 2 gives you 3. 2 plus 2 gives you 4. 3 plus 2 gives you 5. When it's 4 and n is 4, 4 plus 2 gives you 6. Can you see that? So that one is fine. This one a little bit B, that sequence there. Well, I'm going to rewrite that sequence. It's 3. 1 can be written as 3 raised to the power of 0. 1 over 3 can be written as 3 raised to the power of negative 1. 1 over 9 is nothing but 3 raised to the power of negative 2. Okay, so my rule is going to be, or the next one, the fifth one will be 3 raised to the power of negative 3. Well, when you punch this in, you'll get 1 over 27, no problem. Okay, that's what that gives. So my rule must have a 3 raised to the, okay? Now, that is the 3 raised to the that I'm interested in. So I'm going to take the indices here, and I'm going to find out what is the rule that connect them, okay? So when you look at those indices, you will see that they form a sequence that is arithmetic. So 1, 0, negative 1, negative 2, negative 3. The first term is 1. My common difference is negative 1. If you work it out, 0 minus 1. Therefore, the rule for that is going to be first term of 1 plus n minus 1 times the common difference of negative 1. Well, this cleans up nicely to, that's going to be 1 to 2 plus, is it? If you look nicely, you're going to have negative n plus negative n. Okay, you're going to have 2. Just want to make sure my common difference is negative 1. My first term is 1. Okay, 1. Common difference is negative 1. All right, so when you multiply out here, you get a positive 2 and a negative n. So this 2 minus n is what is going to be the exponent. So that's my rule over there. Well, for part C, straightforward, negative 1, 0, 1, 2. Well, that one is 3. Okay, so we need to find our rule, or we need to find what is the nth term. So that one will be 3. So for part C, I'll just do it maybe under, to find, maybe I'll do it on, yeah, let's do it under negative 1, 0, 1, 2, 3. So for C, it's negative 1, 0, 1, 2, 3. Using the same logic, you can see that's arithmetic. The first term is negative 1. The common difference is 1. Okay, you can say this is the first term, second term, third term, 1 minus. So if you want to find the common difference, you can say the third term minus the second term. You will see that you get 1. So my formula then, my rule then will be a, which is negative 1, plus n minus 1 times my d, which is 1. Okay, of course, everything there will be negative 1 plus n minus 1. So it's n minus 2. So my rule for this one is n minus 2. Good. So I'm going to write n minus 2 over there. Okay, that takes care of the part A of the question. Part B of the question. Which term in sequence A is equal to 36 over 37? This question has been terribly answered by the learners because they look at the number on top. They thought this 36 over 37. This is not a term in the sequence. The sequence, if that was 36, if you're looking for the 36th term, then it would not be 36 over 37. All right. The 36th term would be 36 over, guess right, over 38. It's always 2 more. Can you see that? It's 1 over 3. So this one is always 2 more than the numerator. Can you see that? So 4 is 2 more than numerator. 5 is 2 more than the numerator. 6 is 2 more than the numerator. 7 is 2 more than the numerator. So if you were to look at the 36th term, it would be 36 over 38. So this is not a term in the sequence. There is a term of a sequence that when you are writing the sequence as you go along and you simplify that or so, it's going to equal to this number 36 over 37. That is what you must understand what that means. So you use the rule. You can say, wait a minute, I take my rule, which was n over n plus 2, let it equal to 36 over 37. Now you can go ahead and cross multiply. Okay, so cross multiply, you get 37n equals 36 in bracket n plus 2. That is 37n equals 36n and plus, and 36 times 2, 36 times 2 is 72. Okay, if you were to continue, you will be saying 37n minus 36n equals to 72. And n is equal to 72, which is the answer that we are looking for. Which term? The 72nd term. The 72nd term. What will the 72nd term be? Well, let's look. The 72nd term will be 72. 72nd term will be 72 over 2 more than this, 74. Okay, that's what the second is. 72 second. 72 second is 2. 72 72nd. There we go. We got it. If I was to divide this by 2, for example, I would get half of 72. That is 36. Half of 74. That is 37. Do you see what I'm saying? 36 over 37 is not a term of the sequence. If the 36th term would have been 36 over 38, it's always 2 more. But what term in the sequence is equal to this number? We realize it's the 72nd. Tongue twisted, tongue tied. 72 over 74. That's it. Mr. Max here with the work of working out the question paper. So for ordinary level, I just have one more question paper, the one that I gave to my grade 11s in September, paper 1, and then you have quite the question paper bank. Good luck with your studies.